The activity for today is in your textbook. It's those 4 problems from pages 186 to 187. These problems are also copied below. Let u equal log of 2 and let v equal log of 3. Evaluate the following expressions in terms of u and or v. There's an example here. Log 9 could be one of the things that would pop up down here. So how can I take log 9 and rewrite it as something in terms of u and or v? So it's going to turn out that the things that we're going to be allowed to play with here are the number 2 and the number 3, as well as the number 10, because this is a common log. So anything with 10 is nice. So 2s, 3s, and 10s are the numbers that we're allowed to play with. So what we do is we take the number 9, rewrite it in terms of one or both of these guys. So it turns out that 9 is really 3 squared, right? 3 squared. That has nothing to do with this 2. That 2 is independent of this 2 up here. And then once you've written it as log 3 squared, you take advantage of that property that says log of something to a power. You can take that power and move it right down into the front. So that 2 gets picked up and put in the front. And that's what's written over here. And then log 3 is just called v in this problem. So log 9 is really just 2 times v. That's it. So the goal is to have something with only u's and or v's in it. So I'll just write down what the rules of the game are. We're going to try to build the numbers that are inside of the logs in these problems. And the things that we're allowed to use are 2 and 3 and 10. And then only certain operations are allowed. So we're allowed powers. We just saw 3 squared in that example problem. We're allowed multiplication. And we're allowed division. And addition and subtraction are really not useful to us at all. We'll see why. So let's try part A, log of 6. So can you build a 6 using only 2, 3, and or 10, and only powers, multiplication, or division? So log of 6 is equal to log of, so instead of the number 6, we're going to write 2 times 3. We're using 2 and 3 and multiplication. And the reason this is a good thing to do is that one of our properties of logs has to do with the log of 2 things multiplied together. So if you go and you look in your notes, you'll see a property that says log of a times b is really equal to log of a plus the log of b. So that's what we're going to use here. Log of 2 plus log of 3. And then we're just about done. Log of 2 is called u in this problem, and log of 3 is v. So our answer here is u plus v, and that's it. So if that makes sense, and you haven't had a chance to really think about doing B, C, or D, then maybe pause the video here and come back when you've given it a good try. We're moving on to log of 0.08. So trying to use only 2s and 3s and 10s. All right, so 0.08 doesn't seem to have anything to do with the number 3. 0.08 is even, there's a decimal, so I could maybe envision using a 2 or a 10, maybe both, but 3 doesn't seem to fit in here. Okay, I'm going to rewrite this as a log of, and then we'll make a fraction, 8 over 100. Same as 0.08. And then things are pretty groovy, actually, because fractions division is allowed, right? We're allowed to use division. And 100 has an awful lot to do with 10. In fact, it is a power of 10, so that seems like a good way to go. This is really 10 squared on the bottom. And then 8, can we get 8 in there using only 2, 3, or 10? Yeah, 8 is actually a power of 2. 8 is really 2 to the third. And it makes no difference that that 3 is this 3. We could have put 5 up here if that helped us. You could put any power you want. But in this case, it happens to be 2 cubed. Okay, great. All right, so now we got to pick the right property. We do have a property of how to handle log of x to a power. We know that the power can get picked up and go in the front. So that seems appropriate because we do have some powers in here. But we've also got a property that says if you have log of a over b, then you can write it as 2 logs with subtraction in between. So we got to decide which of these 2 properties applies first here, because you got to pick the right one. So first and foremost, is it 1 thing to a power, or is it 2 things divided by each other? Hopefully we said it's the latter, 2 things divided by each other. So let's go ahead and use that division property first. So this becomes log of the top thing minus second log of the bottom thing. So this equals, and now we can use the power property. Powers can come down 3 times log 2 minus 2 times log 10. And actually, come to think of it, I don't want to use that property here. Let's use a different one. Log of 10 squared is something nice. Remember, there's a hidden 10 down here. And when you see log base 10 of 10, they cancel. So that all turns into just subtract 2. So this is just equal to 3 log 2, but log 2 was u, so this is 3 times u minus 2. There's our answer. All right, moving on to part C. It says log of square root of 3 halves. Okay, I see my 3 and my 2, and I see division, so the only issue here is that square root, and we need to rewrite it, because square roots are not in my list of things I can handle. I can handle division, multiplication, and powers. Square root is actually also known as one of these things. Which is it? We know we can rewrite square root using a power. So this is really log 3 halves raised to half. Square root we know is the 1/2 power. And again, you got to pick the right rule. On the one hand, there's division, and we know how to handle log of division. On the other hand, there's a power, and we know how to handle log of a power. Which one comes first? This one is fundamentally a power. You don't even really get to see that there's division there. This power is the overarching rule first. So the power gets picked up and moved to the front. And then we have our division rule. I'll write this down here. 1/2. So division becomes subtraction, log 3 minus log 2. I've made a subtle but easy to mistake error. Can you find it? That 1/2 was being multiplied by the log, the whole log. This is equivalent to this. 1/2 needs to still be multiplied by the whole thing. 1/2, okay, and then finally log 3 was v, log 2 was u, and there's our answer. Okay, and then the last one is part D. Part D is the log of 5. Trying to build a 5 using the 2 and or 3 and or 10 and only division, multiplication, and or powers. So how can you build a 5 using those numbers? Well, we can take 10 and divide by 2. This is log of 10 halves. And then division becomes subtraction. Log of 10, that's one of our nice properties. Log of 10 is on, it's in our list of properties. You should know that that's 1. Minus log of 2. And then log of 2 is actually also known as v. So this problem is 1 minus v. Okay, moving on to 34. Find a possible formula for the exponential function in S in figure 5.3 if r of x is equal to, and then there's the formula for r of x. Okay, trying to find the formula for the function S. So here's the function S. We've done a couple of examples in class where we have found a formula for an exponential function given 2 points. So are there 2 points that are on that curve S? There are. So basically this problem is asking if you can find the coordinates of these 2 points. If we can find the coordinates of those 2 points, then this problem becomes equivalent to one that we've done already. So let's see if we can find the coordinates of those 2 points. Okay, first one first. Let's see. This point over here on the left, maybe I'll make these different colors. So the left one can be green and the right one can be red. Okay, so we'll write in green here. So we're looking for the coordinates of that point right up there. So how much is the x coordinate? Well, the x coordinate is given, right? The x coordinate is right down here. It's 4. So far, so good. How about the y coordinate? Looks like the y coordinate is also given. It's right over here. It's 27. Super. Okay, now let's take a look at red. Unfortunately, I don't think red is going to be near as easy because the x-coordinate of red, so we're looking for here now, x-coordinate of red is not given, and then the y-coordinate of red also not given. So we got work to do, but we do have information we haven't used yet, and that's that we know the formula for the r of x curve. Okay, so what are we going to do here? Well, let's take a look at this point here, the one that's on blue. It's on R. Okay, so this point right here, what are the coordinates? Well, the x is given, that's straight down here, that's a 4. The y, it's not given in the picture, but look, you've got the formula circled in purple. Couldn't we find the y value when x is 4? Let's do that here. R of 4 equals 5 point blah blah, 1 point blah blah, raised to the 4th power. Okay, good. We can find the y value. So we'll turn this through on the calculator. And we'll get, well, pretty close to 8. Let's just call it 8. That's around 8. So that means that that red question mark right there turns out to be 8. So is that the x or y coordinate of this point right here? That's the y coordinate. Great. Now we need to find the x coordinate. Okay, how are we going to find the x coordinate? Well, it seems like we've already used one point that's on the r curve. How about we look at the other point? Do this one up here in black. It's already black. Let's look at that point. What do we know about that point? Do we know the x or the y? Well, if you go straight down, you see a question mark, so we don't know the x. But if you go straight to the left, we know the y is 27. So given that y is 27, and given that you know the equation of that curve, it's circled in blue, can you find the x? Let's write that equation. 5 point blah blah, 1.1169 to the x. I don't know that, but I do know that the y value is 27. So if we can somehow solve that equation, we will have our x value. So we'll divide by the 5.14. I'm going to do 2 steps in one here. Now that the exponential part is isolated, we can take the log of both sides. I'll use ln. You could use any log that you want. But really the only two reasonable choices are ln or common log. And then we get to move that x to the front. So let's see, ln of this stuff. X comes down to the front. And then finally, to solve for x, we'll divide by the ln of 1 point stuff. So x equals okay, we'll type this into a calculator. The other number we typed into a calculator looked horrible, but came out to something nice, like 8. Won't be surprised if the same thing happens here. $15 and just a tiny bit, we'll call it 15. Okay, so that's the x coordinate for the black point. So we can now fill that in. The 15 that we got here goes right in there. But oh, wonderful, that's exactly the other question mark that we were interested in. So ultimately the point that we have here is 15, 8. And so this problem now becomes, can you take these 2 points and find an exponential function that hits them? So this is a lot easier now. Let me just write down the 2 points down below. Okay, and then we'll go with our standard f of t is a times b to the t, and then we'll plug in. So write down the 2 equations that you get. Solve the top equation for a. The goal here is substitution. Plug this into the bottom equation. Something is wrong. Okay, and then we can clean this up a little bit. 8 equals 27. Keep the base, subtract the powers. You get b to the 11. b to the 11 is 8/27. And then 11th root of both sides. So we can type this in and get a decimal. About 0.9. Okay, and all that's left to do now is to go back and find the value of a. So we'll take that and come back over here, and we're going to use the equation that says a equals right there. A equals 27 over b to the 4. b is 0.9, roughly. So we'll type this into the calculator. So we go 27 divided by, but instead of typing 0.9, which is rounded, and instead of writing all that out, just do second answer. And that's supposed to be raised to the 4th power. About 42. So that means our final answer after all of that work, function that we're after, a times b to the t, that's this. A turns out to be about 42. B turns out to be around 0.9 raised to the t. Moving on to the next page, in problems 35 to 51, solve the equations exactly for x or t. So let's try 50 here. Log 1 minus x minus log 1 plus x equals 2. Telltale sign in this problem is that there are 2 different logs. We'd like to be able to merge them together to make 1 log. When you see subtraction of 2 logs, you can merge them together using division. This is one of our properties that we've used today, but going the other direction. And now that you have just the 1 log, you can write in the invisible 10 if it helps, and then follow the football pattern. 10 to the 2nd, copy the equals, and then write the stuff in the parentheses. No log. And so this equation is going to be easier for us to solve. There's 100 there. We're going to multiply both sides by 1 plus x. Distribute the 100. Add x to both sides. This becomes 101x. Subtract the 100 from both sides. And then divide by 101. Again, 2 different logs in the problem. Combine those 2 logs together to make 1 log using a property of logs, and then use the definition to convert the log equation to the corresponding exponential equation. 56. Because they are so large, it is impossible to compare directly the 2 numbers 2 to the 2 to the 2 to the 83 and 3 to the 3 to the 3 to the 52. Certainly our calculators would not be able to handle these numbers, nor would our computers. Instead, first simplify ln of A and ln of ln of B, and then use a calculator to determine which is larger, A or B. Okay, so let's make sure we are clear on what's going to happen here. So at this point, I guess we don't really know what the graph of ln of x looks like, but hopefully I won't be giving away the ball game when I tell you this is the graph. The important characteristic for this problem is that the ln function is increasing all the time. So if you were to look at, say, ln of A and ln of B, and let's just say that A is here and B is here, just to say that A is smaller than B. Maybe it is, maybe it isn't. Then if we go up to the curve, then we get ln of A is this y value, and ln of B is this y value. And as you can see here, if A is smaller than B, then ln of A is smaller than ln of B. Say it and I'll write it. If A is less than B, then ln of A is less than ln of B, since y equals ln is increasing. So that's useful, because what we're going to do is end up trying to figure out which one is bigger, ln of B or ln of A. And whichever one is bigger, well, the corresponding thing without ln in front of it is also bigger. And these numbers are so big, we're going to need to really shrink them down by taking ln twice, but it's the same property, just use it again. So let's go ahead and take a couple of ln's here. So ln of A. Okay, so we're going to write down A, 2 to the 2 to the 2 to the 83. So we're going to use our property, which says that if you have a power, you can bring it down in the front. Now, which one of these numbers right in here is the power? Is it the 2? Is it the other 2? Is it the 83? It's actually all of them. This thing right here acts as a monstrous power, and it, as one thing, comes down to the front. 2 to the 2 to the 83 times ln of 2. That will circle in green because that guy is the one that went down into the front. Okay, so we've brought it down to a little bit more reasonable size, but still 2 to the 2 to the 83 is enormous. I can't even fathom how big that is. So let's do it again. Let's take ln, well actually, we're doing it again, I just didn't write it correctly. So let me copy what I just wrote. 2 to the 2 to the 83 is in the front. ln of 2 is on the back. This is circled in green because it's the same as this. But what I neglected to write down was this ln right here is still here. Just forgot about it. So it's still ln of all that stuff. And now we can make use of another property of logs that says when you have log of a product, you can separate it into two different logs with a plus sign in between. And the second ln, the ln of ln of 2, no problem. We can type that on the calculator. It's going to be tiny. But the first one, ln of 2 to the 2 to the 83, we can bring the power down in the front. So let's bring that power down in the front. And the power in this case is here. 2 to the 83rd is going to come in the front just of the first term, not both terms. So I'm running out of space here. I'm going to sneak down here. So this is equal to, so the 2 to the 83rd comes down in the front times ln of 2 plus ln of 2. Circle the 2 to the 83 in the front. That's the power. Okay, so I guess we could do this one more time if need be. 2 to the 83rd is ridiculously large, but can the calculator handle it? Let's see. 2 to the 83. Cross your fingers. Oh, that's happy. So 9.67 E24, that means times 10 to the 24. What does that mean? So then we can just do that same thing again now and type in the rest of this. So that's times ln of 2 plus ln of 2. And our final answer is right there, 6.7 times 10 to the 24. Okay, we don't really have a whole lot of space left over for the other one. Let's see what the other one was. 33352. I put it way down here. ln of b. 333, and then a 52. Okay, how about we just jump to the answer? Well, I'm going to jump to the answer. You should pause the video here. If you haven't done this one yet, see if you can mirror what we did up above with the 2's. Come back when you're ready. Okay, so I'm going to jump to what I hope is the answer. I think I can follow this pattern here. I'm going to put a 3 to the 52 in the front, ln of 3 plus ln of 3. Okay, I think that's right. I'm going to type this into the calculator. Again, it's enormous. 3 to the 52nd power is very big. Let's just see how big that one is. Ooh, pretty darn close, actually. So let's type in the whole thing now and see what happens. Second entry. Okay, so we're going to multiply this by ln of 3, and then plus ln 3. Okay, we're going to try to compare to this guy right here, 6.7037, 7.098. Same power on the ends, so we'll call that a 7.1 times 10 to the 24. And so our big conclusion here, we've seen that ln b is definitely greater than ln a. So it is bigger than a. Therefore, 3 to the 3 to the 3 to the 54, goodness, is greater than 2 to the 2 to the 2 to the 83. Except it wasn't 54, was it? 52. Yeah, that's pretty nuts. So that's our big conclusion. We mentioned in class about how logs are capable of helping astronomers handle large numbers. You can see that they took these grotesquely large numbers, 2 to the 2 to the 2 to the 83rd, and brought it down to size. I mean, 10 to the 24 is still enormous, but at least it's something that we can get the calculator to give us.